Hey, this is OXDF, and today we're doing Advent of Code 2022, Day 17, Pyroclastic Flow. Um, so we're in this very tall, narrow chamber. It's 7 wide and infinitely tall, and there's rocks falling. And we're going to predict how they fall. There's 5 shapes of rocks. The line, the plus sign, this kind of inverse L, a vertical line, and a square. Um, and they're gonna fall in this order. So one like first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, tenth, etc. Repeating. Um, I'm also gonna get my puzzle input, which is the jet pattern in my cave. So it's gonna look something like this. And so there's gonna be pushes to the left and pushes to the right. And basically the rocks are gonna fall. The rocks come in with 3 spaces between them and whatever's the tallest thing in the cave. Uh, and then we alternate. We apply a jet pattern, which moves right or left. If it can't move right or left, it just doesn't move. That's fine. And then we move down one. And if we can't move down one, that rock becomes kind of a permanent thing. So you can see they show that here by turning it into hash marks or pound symbols. And so then the next rock begins falling. And so it gets pushed, it goes down, it gets pushed, it goes down, etc. until it hits the bottom. As soon as it's touching here, it gets pushed again. And then when it tries to fall but can't, it locks in. And the next rock comes. And so the question is, after 2022 rocks have stopped, what is the height of the tower? How many units tall will the rock tower be? So let's jump over and give it a try. Genday 17. The code for this is in the repo linked in the notes below. And I went over it a little bit in detail in the first video, but it pulls the input for me and gives me a stub to work with. Nothing too surprising here, except for my jet stream is way longer than the example. I guess we could do a input.text, so over 1,000 characters. Shows you we are going to be falling a lot because they expect us to repeat, but okay, we'll go for it. So yeah, that's fine. I'm going to do a class for this one because it seems like a good way to help me organize my thoughts. I'm just going to call it like game. And we'll do def dunder init. And that is going to take stream and let's see. So we will do self.stream equals stream. We're going to need some other things here, right? So we're going to need to know self.rock number. And we'll start that at 0. Like that's just because that's gonna help us as rocks come out. We're gonna need to know: A, are we hitting our Are we hitting our thing, our goal to 2022? But also like which one comes next. We also are gonna need to keep self dot. I guess we'll call it like stream ID. Set that equal to 0. So that's gonna be like what move are we on next? So that's good. Let's see. We also are gonna need things like not really self. I guess we can call it well, we'll call it self dot left wall equals 0, self dot right wall equals, and so in the diagram we have, let's see, so 0, this is gonna be our 0, 1, 2, 3, 4, 5, 6, 7, so this will be 8. We'll have that. We could have hard coded that, but it could change, and I just want to, it'll be easier to think about it as that. Let's keep a self.height because when a new rock shows up, we're going to need to know to start it 3 above with 3 spaces and then above that, and so it's just going to be useful to keep that rather than having to calculate it. We're going to need a self. I'm going to call it grid equals a set, and then we're going to think about what is that grid going to look like. At the start, actually, it's going to, let's see, for I in range, we'll give it 0, comma. I guess we don't really need 0, but we'll go for it anyway. 9, cover both walls, self.grid.add, and in there we're going to add the point, we can call this I, comma 0. So that looks good. That'll give us our floor because we want to just check we'll add our floor to the grid basically. I think that sets us up. So now what are we going to do? We're going to say we're going to need some functions here, right? So we're going to need def step, let's call it step. And in a step, we're going to, let's see, we'll come up here and let's see. In a step, we are going to push by stream, and then we're going to fall. Okay, so let's might as well have a def push, and we'll say like left equals true pass, and we'll need a def fall pass here. Just sort of laying out my functions here, so we can do like, if we're falling, we're going to say if can fall, all points move down. If can't fall, then we lock in update height get new rock. Oh, I guess we need a rock. Self.rock equals, we'll make it none for now. Or I guess we can probably, we're gonna need, okay, so we're gonna get new rock. Let's see. We're gonna also do a def new rock. And that's gonna take a num, I guess. And we'll do this. And so now we can say self.rock equals new rock, self.rock num right there. So now we're going to have, oh, I guess it's self.new rock. There we go. So now we'll initialize it to getting the first rock. We can do the falling. And then whenever we need to get a new rock, we'll call new rock. I think that's all we're going to need. So now we can start to figure out how to make these things work. So what are we going to do here? We're going to we've got this set up to get one rock to fall into place. What are we going to do? I guess, do we want to think in terms of steps? Now, steps aren't really important other than we kind of need to know if we're done. So what we're going to do here is we'll say def drop one rock. Let's make that our main function that we call. So to drop a rock, we are going to call step. Maybe we don't even need step. Maybe we just do these things in here. So the first thing, we're going to do a while true. So first we're going to push the rock by the stream, by the stream, right? So we can say if, I wonder what the good way, is there a good way to get I wonder if there's a good way to get like this as a just as an iterator. I guess we just do if self.stream sub stream ID, I mean self.stream.self.stream ID. Why is this not coming up? Weird. Equals that. We will, if we had a push self.push, and this will be true. Else, I believe everything, we verified everything in here is either left or right. Yeah, so there's no, okay, so we can just say else self.push false. Oh, we can probably, just make this self.push self.stream equals that. There we go. Why do we not? What are we unhappy with here? Oh, we should pass in self. There we go. Haha. Okay, all these functions are going to need self. Okay. Okay, so we're going to push by the stream. Then we're going to call self.fall. And that's not going to need any input because it's just going to fall. And we'll say if self.fall, if we've reached the end, we'll break. Okay, so that's gonna, and so self.fall is gonna return true. Let's see, return true if can't fall. Let's see, we'll say return false, return true. There we go. So now we can drop one rock by doing by pushing ourselves and falling, and then if we hit the bottom, we're done. We break. If not, we're good. Okay. So our drop one rock looks good. Let's do our push here. So if we will say if we want to push to the left, so we'll say if left dy. I guess we can do. Let's do dy equal dy equals -1 if left else 1. So then if we say let's say x comma y for x comma y in self.rock. So this is going to be our rock. We are going to get for each piece of our rock, we're going to get a coordinate, right? We're going to say we don't care about the x at the moment. We're just checking. We're going to check and see if we're in the wall. So we'll say if y plus dy, that'll be like a new y position. We can say y plus dy 0 is greater than there, less than 8. And that'll keep us, so as long as that's true, that means we haven't hit a wall. So we want to say all if all that, and we need to also check and see if it's going to hit any other rocks. So we'll say, we'll do the same thing here. We'll do x comma y for x comma y in self.rock. So we'll get all our positions. And for each of them, we want to say is x comma y plus dy in self.grid. I guess we want to say not in self.grid. We want to say all around this again, so we can look at a generator. So if all of the new y positions are within bounds, don't hit a wall, and all of the new y positions are not in the grid, or we're not going to hit a rock. I think we might need a thing there, or that's a backspace there. So if those two things are true, then I'm curious to see how black formats that, but let's leave it all in one line for now. Then going to I guess we'll just do it the same thing, right? We'll do x comma y plus dy for x comma y in self.rock. And we'll make that a set. And we'll say self.rock equals that new set. So now we've moved the rock in the right direction, in the direction. If we can move it. And that's it. That's it. If we can't move it, we don't do anything. So we're done with the push function. Now we need the drop. Now we need the fall function. This is gonna be a little more complicated, but it's gonna be very similar. So we're gonna first say, actually, I'm not sure it is much more complicated because we don't have to worry about walls. We just have to say if all, and we'll say x comma y minus 1. So if the tuple x comma y minus 1 for x comma y in self.rock, Okay, so if all of those tuples not in self.rock, if we can move down one, oh, but no, we can't, that's not quite right. Oh, and this isn't quite right either, because this is tricky. Okay, because go here, when I need to move this one left, I only care about the empty spaces on the side. I don't care about like this one is going to be on top of, this space right here is occupied in the rock, but it's occupied by itself, so it doesn't matter because that's leaving. So I really only have to care about the left edge of the rock if I'm moving left, and the right edge of the rock if I'm moving right. Hmm. Oh, but I'm not checking against the rock. I'm checking against the grid. So I'm fine. I don't know what I'm thinking about here. Okay, so just ignore all that. That was overcomplicating. So for each position in the rock, I think I'm fine here, right? Okay, for each position in the rock, I'm going to check if moving it down one hits me something in the grid. If I get no hits, I'm going to say self.rock equals set of x comma. I think I've just noticed a mistake in my previous one, but we'll go with that. Y minus 1 for x comma y in self.rock. So we move the rock. We move the rock 1. Up here, we shouldn't have been doing a dy. We should be doing a dx. Dx here. X plus dx here for y and da da da. And all x plus dx. Not in self.grid for x. Okay. And we do x plus dx. There. So we're checking when we move sideways with our x positions, and we're then moving down with our y's. Okay, that looks better. Okay, so this is that there. If we can fall, we are going to move all points down, and we're going to return false. Now we know we can't fall. So let's return false. So if we can't fall, we're going to lock in the rock. We're going to say for comma y in self.rock self.grid.add comma y. So now that rock is part of the grid. We're going to say I guess we can also update the height first. So we'll say self.height equals max, and we're just going to get the y values in the current rock. So we'll do y for x comma y. I guess we can do x comma y in self.rock. So the new height will be, oh, I guess it's that plus the old height, because it's possible it actually fell down to the side of an old rock. So we'll do self dot height. I don't know if this is really the right way to do it, but we'll just, so basically this will be combining those two things. So we'll get all the y's in the current rock plus the current self dot height and just get the highest one set to height. Then we can add it here, lock in the new rock, and return true. I don't know what's wrong with my end today. Let's get rid of that pass. Okay, so we now have a fall function that seems reasonable. Oh, we need to get a new rock. So after we do that, we can say self.rock equals self.newRock. And I'm actually not going to pass the number in here because we're keeping that. So we'll do that. Okay, so what does it mean to get a new rock? This is actually going to be a little bit complicated too. We're going to need to we'll say if num equals self.num, self.rock num mod, and I think there's 5 rocks. I better make sure of that. Um, 1, 2, 3, 4, 1, 2, 3, 4, 5. So yeah, so we want mod 5. And we are going to okay, the first one, if num equals 0, self.rock.add. Actually, we can do a for loop here. For x in range, and now we know it's going to come in. They said each rock appears so its left edge is 2 units away from the edge. So it's going to be in 0, 1, 2, 3. So for this first one, it's going to be 3, 4, 5, and 6 are going to be the spots we want. So we want for x in range 3 through 7. Self.raw add x, and then what's y going to be? Well, y is going to be self.height plus, let's go back here. Where's my example? So here's the example. If height in this case is 0, we want 1, 2, 3, 4. So plus 4. Which is weird because it says 3, but I think the way they're talking about 3, we're going to use 4 in the coordinates. And that is going to be the first rock. And then we will do L if num equals 1. In this one, we are going to do, it'll be a little more complicated. So this will be height plus 4, height plus 5, height plus 6. So we might just be doing self.rock.add. Let's see. So this will be 3 height plus 5. I think I'm just gonna 3, 4, 5. The next one will be 4, and then we get height plus. Let's see. This is 3, x equals 3, height plus 5. This will be x equals 3, 4, 5, and 6. We can do 4, 5, and 6, where all of these are at the x position 4, and this will be x position 5 and 5. So I think we're good there for this next one. I don't know why my screen just jumped. Elif num equals 2. Okay, so this next one is going to be for x in range 3, 6, self.rock.add x, self.height plus 4 for y in range, and this will do 5, 7, self.rock.add, and this will be in 5, y. See if that's right. So in this case, we would add at 4 off, we would add 3, 4, and 5, and then at 5, we would add 5, 5, and 5, 6. We'd add as well. I think that's good. Next one is 4 straight up. That's not going to be too hard to do. Elif num equals 3 for y in range. And so we always start with height of 4. So it'll be 4, 5, 6, and 7. So we'll stop at 8. Self.rock.add. And this will all be at 3, y. And then we can say elif num equals 4. What does our last one look like? Oh, a square. Okay. For x in range, and we will be 3, 5, because that'll be 3 and 4. For y in range, 3, 5. Also to get 3 and 4. No, not that. No, not y in range. That y in range, height. Self.height plus 4 to self.height. Oh, actually, let's just do it. Sorry, we'll go back. We'll just do this. We'll do 4, 6, and we'll self.rock.add x, y plus self dot height. Okay, I think we have our five rocks here. And then the last thing we need to do is increment. So we can do else. Oh, well, no, we can be confident we're never going to hit this. We'll do self dot rock num plus equals 1. Okay, so we've now got a new rock and we've updated our rock number. I mean, we might have, I mean, it feels like we've kind of put all these pieces in place without testing any of them, but we might have a solution. What's the best way to do this? Okay, so let's get our input here. It's going to be self dot read dot strip, and then we can say game equals game line. Where that? We can say we can try game dot drop one rock and see what the height is. Let's try that and see if, I mean, I'm sure we're gonna get some errors here, but we'll game.new rock takes 1, 2 were given. Oh, because we don't need this anymore. Game has no attribute rock. Doesn't? Oh, wait, it doesn't. Let's see. What line are we at? 53. Self.rock.add. Do we not initialize self.rock equals self.new rock? Oh, are we getting a little bit recursive here? So we could say self.rock equals set, make it an empty set. Oh, we should, no. We should not do that. We should do it down here. When we get ourselves a rock, we should say self.rock equals set and make it empty. Because every time we want to empty out the old rock and make a new rock. Try that. All right, none type is not iterable. Where am I hitting that? I have one rock. Self.push stream. We're gonna have to run this with minus npdb. Continue. And what does self.rock look like? Nothing. Self.rock is not set. To make sure we're not hitting something weird there. I've just hit, I have no idea. Why would I ever have self.rock equal to none? What if we get rid of this drop and just see where, simplify a little bit? Program finish and we'll start. Okay, what is, okay, instead of PDB, let's do an I at the end. We can do game.rock. Okay, so we're calling game self.new rock up here at the top. We're setting self.rock type type game.rock class of none. Minus mpdb minus c break at line 18 minus c to continue. Okay, we're going to step into self.new rock. We're going to step through this. Self.rock. What do we look like? As a set. Okay. Stepping through this. What does our self.rock look like? Okay, it's a rock. Got a rock number. We return. Return. Let's see what does game look like now. Game.rock. We don't return the rock. We don't need to self.rock equals. We just need to self new rock. There we go. Height equals 0 to start. That's good. Let's uncomment this. And just so in case it wasn't clear, what I was doing was I was self.newRock was setting self.rock, and then it was returning nothing, and then that's setting it over. It was overwriting itself. So 1 high after the fall. That seems reasonable. What if we do 4 underscore in range 2? That should drop us 2. None type is not iterable. Oh, because we probably do the exact same thing here. We just need self.newRock, not self.rock equals newRock. 4. Let's see. The next one falling down was 3. That seems reasonable. Let's go back to our. Well, we could just be crazy here and say. Where do we do this? Instead of this, we could say we want in 2022 and just see if that solves it. It's not like this has been a short video. No, too high. Let's get the example input. Not sure. Okay. Okay. Oh, I wonder. Are we updating the stream appropriately? When we push. No. Aha. We are missing a stream. We're missing our update here. Self dot stream ID equals self.stream ID plus 1 mod len self.stream ID. So basically we weren't updating our stream ID. Oh, and we have no len self.stream. Okay, 3036. Not quite. That's a bummer. Okay, so we can start to compare now. What do we? Let's come back here and try. What have they shown us so far? So we were good for the first couple. So this is 2 rocks in. We were at height of 1, 2, 3, 4. So come back here, and why don't we do for the moment we'll do num to drop equals sys.argv. We already have 0, 1. This will be 2. If len sys.argv is greater than 1, else 2022. And then here we can do num to drop. So just that'll be for testing. So if we do this, we should get, oops, let's see. that, we get the same. And if we put in 1, we get int. If we put in 1, we should get 1. If we put in 2, we should get 4. Okay. If we put in 3, we should get 7. Let's see what that looks like in the... so the third rock's going to fall 0, 1, 2, 1, 2, 3, 4, 5, 6. So our rock did not fall. That rock did not fall in the right place. All right, we're gonna have to do. We're gonna write a print function. The print self. We will say top equals max of self dot height comma self dot rock. We need, really what we need is y for y, x comma y in self dot rock, like that. So we want to get the highest that plus 2, we'll say. And then we need to just do for row in range top comma -1 comma -1, print for column in range 0 comma 8. Actually, we'll do this. We'll do print. What do they show the walls as? Line. Make ours look nice. Print that, comma, end equals that. Then we'll do for range 1 into 8 if C, I guess we need, yes, C is the X value, comma, R in self dot grid. Print that end equals that. Elif column comma range in self dot rock. Print that end equals that. Print. All right. That actually should do it. When we get to, because we added all the floor to the thing, so that shouldn't be a problem. I mean, it will look nice. It's gonna print those as rocks, but that's fine. All right, let's do it. Let's print. Let's drop 1 rock and then game dot print. So we do 1. Ooh, not supported between list and an integer. Okay, so we need that. Should combine those two into a list. Oh, else print space end equals. We need the space, or it's going to look very compressed. Okay, so at the end we have that looks reasonable. Feeling we're going to want to make a much bigger space here. So if we drop 2, we now have. Oh, so we screwed up our rock. So if we screwed up our one of our rocks, because this looks all right, but the next rock coming in looks completely wrong. So it looks like the y's here are way off. We're off by we're off by 4. So where's rock type 2? It's self dot height. The self dot height should be. Yeah, let's do this. Import pdb dot set trace. So self dot height at this point is still 1. Why is self dot height still 1? We should be updating that before we get a new rock. Well, that's interesting. Why is self.height 1? This clearly is not working out. Move our, grab this up here and move it right here. And run that again. Okay, so what is self.height is 0. Oh, because we're hitting the first one. Okay, so this one, I'm not worried about this one. Let's move on. With the next time we hit it, now self.height is 1. Got that. Self.rock is this. So if I just get the y's, it's going to be that. Plus self.height equals that. Max equals that. So why does self.height not become 4? Did. Okay, so now I'm going to step through. Add myself to the grid. Pulse new rock. We're going to step into that. And we got our rock. We got our num. We're not going to pass there. We should hit here. Okay, we're dropping into. Oh, okay, we're dropping into here. That's fine. So self dot. Oh, why am I adding it as 3-6? Where are we? Okay, so this is relative to self.height. This is relative to self.height. This is not self.height plus that. Same thing here. I need to do self.height plus y. And we look good there. Okay. Let's quit this. Let's find our, let's see if we just, PDB. We'll get rid of that. That looks better. We'll probably want to get rid of that print if we're going to run it forever, but it runs a lot faster. 3068. 3068. Sweet. Whew, we took a journey to get there. This is going to be a long video. 3171. All right. Part 2. So can we do that many rocks? I'm guessing the answer is no. Check real quick. Oops. Let's do it. Let's do an example. Yeah, we're gonna need to think of a smarter way to do this. And I didn't expect it to take so long, so I'm gonna have to actually jump off and finish and come back and finish part 2 later. So, see you in a second. Okay, we're looking at part 2 here. I'm going to pull back up the challenge. I looked at it very briefly, but basically all I have to do is figure out how to go with, let's see, 1,000 million, billion, trillion. So a trillion rocks. We're not going to be able to do this loop. It's clearly too big. I showed that briefly. And I've been thinking about a solution to this. And so let's come back over here. And let's see. So the first thing I want to think about is the fact that if we start dropping in the same pattern over and over again, we're eventually going to see a pattern, I think. And so let's go ahead and let's see. Game 1. Let's go ahead and create a new game for part. So down here, let's say game 2 equals game line. I guess we could probably call it game, but anyway. Num to drop equals, let's deal this from here. But this is not 2022. It's going to be 1. There's 1,000, a million, a billion, a trillion. There we go. We're going to want to remember not to accidentally not pass this. So what are we going to do first? We're going to loop through our game just like we did before. But this time, we'll do like 500 or something. So we'll do for I in range, num to drop. we will game dot drop one rock, and when we're done, we will game dot print. We don't need this one up here anymore. We're just going to ignore it. And because we're going to look at what is going on in this formation. So if we run this on the example with, let's say, like 500, let's see, I'm going to run it into less so I can start at the top, and we will make this much bigger. And as I start to scroll down, I'm kind of just like looking at the patterns I see here. And one thing that I'm starting to notice that I've seen a couple times, I've seen this pattern over here, like from 1428 to 1425 with like 5, then like 2 with space in the middle and 4. I've also noticed this pattern here, this big square where I've got that with, it's like there. There's our 5, 2, and the 4 again. There's our big square again. There's our 5, 2, 4. So we can see we're repeating our pattern. We're repeating ourselves. And the good thing is if we can determine the pattern that's happening and how often it's happening in the space, we can then use math to just sort of like solve out what, propagate, oh, this pattern shows up 30 times. We just know we can figure out the height that's added by that and the number of rocks, etc. So what we're going to want to do, I made my terminal too big. Can I recover it? How do I get my thing back? Day17.py. Close my terminal. Okay. New terminal. No, too high. There we go. Okay. Sorry. Let's see. So we got our terminal. We go into day 17. We can Python day 17 input.text. We want to do the same thing. I think I just did that before with the puzzle or the example. So we want to make sure we have the same kind of thing. Oh, I see. I can just do that, and now, haha, clever. So let's see. Do we have something similar here? So we have this. This looks interesting. Like 5, 2 space 2 or 6. Does that show up again? Might be a much longer pattern. Well, here's our. Was I looking at this before? Here's our. That looks interesting. We can look for that too. I'm not even gonna try to visually. I'm gonna assume. We're gonna assume it does happen. I guess we could do like a 1, 2, 3, 4, 5, 6, and assume that's not that common. So next, or we could say maybe 500 is not enough to get there. Let's do 5,000. Now we can start to look for patterns. So what if we look for this pattern right here? Yeah, it's hard to say. But we'll check it, right? So we'll check it. Let's push this down. So we're gonna build a signature. And our signature, this is gonna be kind of fluffy, right? Because it's hard to say exactly what's good enough to be our signature, but we can say def signature self. And I'm gonna say like, let's look at 40 rows. And if all 40 rows match, that's probably a good sign we've got a pattern, right? So we'll say points equals set, and we'll say for y in range rows, for x in range 1, 8, because we want to start at 1 and finish at 7. We don't want the ends. And we'll say if x, and now here we're going to do y plus self.height minus rows. So basically what we're going to do is we're going to get the top 40 rows. So we're going to get y plus the height, so that'll put us 40 above, minus 40 gets us right to the top row. And then we're going to do that. So I guess when y equals 0, we're going to go from the height 40 down, and then we'll work our way up. So we're going to do that. And we're going to say if in self.grid points.add x, y. And now we're just going to return, and we're going to make a frozen set. And the reason we're doing this frozen set, I believe I did this in a previous video, because I need, maybe in the last video, because I needed something that would be hashable. And frozen sets are hashable. So a frozen set of points, now I've got a hash. I can compare that and see if it's the same. Okay, so I've got a signature. Let's update the drop function here. Where's my drop function? Fall? Or let's do drop one rock, I guess. So we're gonna check, we're not checking each fall, we're gonna check the end of the rock. So we'll say, after this loop, we'll say sig equals self dot signature. And now we want to have we want to track signatures. So let's go here and say self dot signatures equals an empty dictionary. We can say self dot signature. Let's see how we're gonna do this. We'll say, actually, let's see. We'll say if sig in self dot signatures. That means we've got a hit. We've seen this exact signature before. We can do print. Let's print a bunch of data. So right, we'll do repeat at self dot. We can say h equals self dot height, r equals self dot rock num, prev at, because we've got the previous one, right? So we can say prev at self dot signatures subsig, and we can leave it for that for now. And then we will update self dot signatures subsig. Oops, let's see. Subsig is equal to, and we'll say self dot height, self dot rock num. Okay, so we think we get that. Now let's save this and let's run this again. Okay, so we got a bunch of stuff here. And so we get some hits. We get some, actually, hold on. I want to make sure. I want to run this first on example. Do 500 into less. So we're getting some hits here. We get 6, and so it looks like once we get past rock 40, we're getting hits all the time. Everything is a hit, and that's exactly what we want to see. That means we have a repeating pattern. So now let's try it on the main one, and we can see on rock 206 we get a couple like one-offs here. Oh, sorry, let's check. We should be looking here. We get a couple one-offs here, but then we get, so it looks like once we get to 2598, now we're hitting every time. And that's good. That's what we really want. So what that tells me actually is our signature is not great because we want to get rid of, these are all basically like false positives. So let's see if we can make our signature a little bit better. Right now we're just looking to see if the rock formation is the same. Let's also see if let's look at what the next rock shape is going to be and put that in there. We can do that actually. We'll just kind of create a fake point here, and we're basically going to say self dot rock num comma like that. Put another point in here, and by doing that we just sort of add to the tuple another thing that has to be the same. So if we quit and run this now, where did I print? Or did I get no cache hits? Let's start working with our. Did I get no cache hits, huh? Maybe I didn't do that well. We definitely don't need to print. Let's get rid of whatever we're printing. Save. No cache hits. Okay, so that was not a good one. Add those in. Did I not do enough? Oh, because I'm not adding self.rock number. I need to add self.rock number mod 5. Okay, that was silly. Yeah, there we go. So now I get hits 66 and just onwards. Interesting, 68 misses. So maybe, oh no, I'm looking, those are the heights. The heights doesn't always change. Here's 40, 41, 42, etc. Heights are looking the same. Rocks are getting hit every one. Let's try at our input. And here we go with, we are getting hits at rock 2598 and beyond. So once we start getting there, we've got a good signature now where we're getting a hit every time. Okay, so this is cool. So what do we need to do now? Well, we want to go back to this game loop. Where's our game loop? And we want to say, we're not going to run this many times. What we're going to do is we're going to do a while true, and we're going to say, we need to figure out if we get a cache hit. So let's come back up here and we'll return in our drop one rock here. We can say hit equals none. Actually, let's return the let's return the delta between the delta. So watch this. We'll say none, comma, none. So if we get a hit here, we're going to comment this out and we're going to return, we're going to set hit equals, and we want it to be the delta. We should look at that delta actually. So let's say, actually before we do that, we'll go back and look at what that delta is. That's what I really care about. And I'll show you what I mean in a second. Okay, there we go. So we're back to here. Can we do this again? Sweet, we're getting hits. Okay. We're going to run this, and we want to add to our print statement. Let's make this a really long, gnarly print statement. Delta rock, and this will be self dot rock num minus self dot signatures sub sig, and that rock number is the second one, like that. And I don't know why I went outside there. And we can do h, and this will be like self dot height minus self dot signatures sub sig sub 0. Because now let's run this again. Oops, let's see. What do we have? In my self dot signature. Where's my signature? I must have undone one too many times here. 5. So we can see this delta, and this is what's really cool. Now the delta is the same every time. And that's what we really want to see here, is that this delta is constant. And that's okay. So now that we're happy with that, let's come back up here. We will comment this out, and we will grab this, and we will set hit equals self.height like that. Up here we can say hit equals none, comma, none. So now we're gonna, and at the bottom here we will return hit. What we're gonna do now is we're gonna return none, but once we get a repeat, we'll return the hit. We probably don't need to, that's probably overly complicated, but it'll work for now. So let's comment this out. And we can do while true. DHDR equals game2 dot drop. Oh, I've been running game 1. That was weird. I probably should have been, that might have been messed up too, but anyway, it's fine. We'll figure that out. Game2 dot drop 1 rock. Now and then we say if DH break. So basically what we're going to do is we're going to run until we get a cache hit, and then we're going to stop. And now we just got to do some math, right? So we can say rocks left equals num to drop minus, and then we're going to do game2 dot rock num. Now, but I actually already increment the rock number, so we're going to add one more back into this because I'm going to subtract off one too many there. So now the number, we can think about, like, we're going to add some fake sections, right? So let's say we were trying to get to 1,000 and each section was 100 and we were at 50, right? Well, we'd want to add 8 fake sections in there that we could just skip through to get us back to 950. 9 fake sections to get us up to 950, and then we drop rocks till we got to 1,000, right? So what we'll do here is we'll say like fake sections equals rocks left divided by dr. That's how many rocks are in each section. Then we can say more drops equals rocks left minus, I guess we can do fake sections times dr. Because this is an integer division, so we'll round down. So we multiply back up, we'll get the number of rocks we need to do. So we can do for I or blank in range more drops. Game2 dot drop 1 rock. Now we'll be at the place where we can say part 2 is equal to game2 dot height plus fake sections times dh. So however many fake sections we have plus however high they are. And if we run this, it's going to run pretty fast. We don't need the less anymore. We don't need that. Let's run the example first just to take a look. We get 1514 ending in 288. And that is 1514 ending in 288. Feeling pretty good about that. Let's see if this works on our input. And we get an answer. And we got it. Neat problem. Really neat challenge. It took me a long time of like walking around during the day, hanging out with my kids, figure out the strategy for part 2. But once it clicked, it was not too hard to implement. So I'm going to call it there. Longest video of the year by far. If you made it this far, thank you so much for sticking around. I appreciate your support, and I'll talk to you next time. Bye.